Good afternoon to all. Welcome to the MIT Portugal session. First of all, I would like to welcome you all, and also I would like to welcome one of the high school students, André Breda, and he will talk about CanSat Junior. Welcome.
Hello, thank you all for letting me be here. Small correction, I'm not a high school student. I'm actually in university, in Instituto
I know.
studying computer
Welcome, André.
science. So, CanSat Junior is a continuation of sorts of the larger scale CanSat project organized by the European Space Agency. Me, together with one of my IST colleagues, Filipe Almeida, Portugal and Ciência, Viva, organized a competition for students aged 13 to 15 years old to build a satellite the size of a soda can and launch it a bit up in the air, collect data, process that data, and present it. With this, we hope that we can attract more students to STEM fields and space exploration, get them excited about space exploration in general. And with this, in essence, what I want to tell you is that whatever wonderful projects that MIT Portugal and other institutions work on, you can rest assured that they will be carried on by future generations.
Thank you, André. Thank you so much. Okay, so now we're going to show you all a video from the MIT Portugal project. So hope you enjoy it.
As humans, we thirst for knowledge. We ask profound and difficult questions, and we yearn to understand our role in the universe. We are constantly adapting to an ever-changing world where unforeseen challenges arise and age-old problems only seem to worsen. That's where the MIT Portugal Program comes in. A collaboration which inspires a unique environment where science, technological research, and education all flourish.
MIT Portugal has a history of turning research projects into products and solutions. This collaborative ecosystem targets innovative research projects with the potential to address complex global challenges like climate change and building sustainable cities.
Since 2006, the MIT Portugal program has facilitated academic and research opportunities for students and faculty. The program has also developed an international partnership of global players with a common goal of creating a sustainable impact on people, research, universities, and industry.
We love the collaborations between faculty, students, and researchers from MIT and Portugal. We all share a culture of hard work and a focus on sustainability. I know MPP will continue to thrive as we create new opportunities for the MIT Portugal community.
Our thirst for knowledge is never fully quenched, as our questions never cease. The MIT Portugal program challenges the global community to engage with cutting-edge research and ideas.
We promote a series of activities to challenge the community. For example, the Blue Origin Payload Competition, where Portuguese university students work with MIT teammates to design a nano experiment to fly with Blue Origin's New Shepard rocket. We also have workshops on digital transformation and data science as a driver for research development and many other opportunities for students to study at MIT and in Portugal.
MIT Portugal program wants to change the world and leave an indelible mark by driving research and innovation in 4 emerging areas: climate science and climate change, earth systems, digital transformation, and sustainable cities.
Last year, MPP launched several initiatives that funded 7 flagship projects and 35 seed and exploratory projects. We also funded 40 PhD doctoral grants for students studying in Portuguese universities. Each of these is a collaboration between the Portuguese R&D ecosystem and MIT.
In the end, we know that all our answers will only create more questions, and the cycle will continue as the world evolves. MIT Portugal Program.
I would like to welcome now to the stage Pedro Arezes, our National Director of the MIT Portugal Program.
I think it's safe to take the mask out here. So, good afternoon, everyone. Dear MPP fellow directors, Zita, John, and Doug, who I think are watching us through streaming. Dear invited speakers, dear attendees, joining us in presence and through streaming as well. So good afternoon, and thank you for coming to this MIT Portugal session. I would like to begin by thanking the organization of Ciência for the invitation to partake in this event that assumes particular relevance given the challenges we continue to face, and by promoting science and research as critical drivers in the decisions of tomorrow. Science that makes tomorrow and transforms the economy, the topic of this Ciência, suits our current situation, in which we prefer to adopt and embrace the world resilience and prepare for the future. And this is where MIT Portugal is also call on action. We find ourselves listening to the old sentence, the best way to predict the future is to invent it, which so well applies to our current days, perhaps even taking on a much more expressive dimension today. The research and outcomes we aim to see developed at the MIT Portugal program, mainly through our flagship project, but also with our seed and exploratory projects, are contributions we foresee to shape or to help shape the near future. And these are challenging times, in fact, but they are also exciting times. Global warming, overfishing, and other human activity-resulting impacts are thus threatening the planet's largest habitat. But the truth is that they push us to do more, to do better, and to do it more efficiently. It is with pride that the MIT Portugal program takes on the role of vector of change, innovation and development, with the certainty that we are working for what awaits us tomorrow is not a world where we survive, but one where we thrive. Our session for the next, let's say, 1 hour and a half will focus on space as one of the new frontiers for science and technology in Portugal. So looking into space also means looking into Earth, and more than ever, one is sure that it can hold key solutions for many of the sustainable development goals that we are pursuing today. The ability to look at the planet from high above can help to better understand the life on land and on water, the climate, the crops, and many other systems. The MIT Portugal program has been putting into action initiatives that aim at establishing in Portugal the capabilities to develop space-related technology, science, and knowledge sharing, all in a strong and active international collaboration domain. So in this session, several researchers from ongoing research projects within the MIT Portugal framework will also share some of their developments and discuss the expected contributions. So with no further ado, I'm now pleased to hand over to my colleague Zita Martins, who will be moderating this session, and to our guest speakers whose research and PhD thesis or plans aim to give several contributions on this matter. So thank you once more for your presence, and I wish you all a good and fruitful session. Thank you very much.
Thank you, Pedro. Okay, I would like to, first of all, to introduce each of the invited speakers of our session, Crossing the Atlantic Through Space, MIT Portugal Program. So on my right-hand side, we have José Freitas from Edisoft, Then we have André Guerra from SEIA, Tiago Ormigo from Spinworks. We have Carrie Cahoy from MIT Online. Hello. And we have Rita Dantas and Rita Pombo, two students from the MIT Portugal program. So to start with, I ask José, André, Tiago, and Carrie to please give us an introduction about your project, Aeros. Thank you.
Hello, can you, this working? Okay. So first I'd like to greet the Ministry of Science, the Ciência, Viva, the MIT Portugal team, especially to our colleagues working in Aeros, present and not present, and obviously all the audience to make this come into fruition in a difficult time. So I will do a presentation of the Aeros. This is an MIT Portugal project. It is also a flagship space project in Portugal, so interesting to say. We can say that the motto is crossing the Atlantic through space and the Aeros constellation. Let's see if this works. Yeah. So, project objectives. I have to look this way because I'm... Okay, so the project is to build the Aeros constellation. It will be based on nano satellite platform as a precursor of future constellations. So the purpose is for this to be the zero satellite of a constellation. It will leverage the space and ocean scientific and economic synergy. So this is a project to cater for the space domain, but also science, and with the underlying business plan to support it. So there will be different payloads. So there will be a software-defined radio, an hyperspectral camera, and a GNSS reflectometry sensor. The platform, it will be a CubeSat, but we will develop the payloads, integration, new software, etc. We'll also work on the ground segment, develop this telecommand and telemetry solution. And very important is the data analysis center. So the data that will be collected by the satellite will be put in a data center. There will be big data analytics, artificial intelligence. There will be feeding of information from ocean models. And all this will be made available to the community, including paying customers, and also to be integrated with data from other sources. The satellite will be launched into space. This is important to mention. So the target is to have it launched in Q4 next year. And we have 9 national partners from academia and industry, but also external partners such as MIT Portugal. Not only, I don't have the full team here. So, okay, yes, I do. I'm sorry. So we started up in November last year. Currently, we have been working on the operation mission requirements, obviously equivalent to a phase A. Then the technical requirements, the business case, this is important again, the projects should be financially sustainable after this phase. We're working on the onboard requirements, design development, the onboard architecture, and we also dealing with the strategy for procurement space parts. So you have the consortium, so CEIA, Edição Universidade do Minho, Instituto Superior Técnico, Spinworks, CIMA, Universidade do Porto, Faculdade de Ciências da Universidade do Porto, DST Group, Collab Atlantic, IMAR Center, MIT Portugal, and it's funded through the MIT Portugal. Okay, so this complex and unreadable diagram, it's supposed to be that way. The purpose is very simple, is to show the amount of work that's been done. So I would like to praise all partners for their involvement and enthusiastic support. And just to say that we start off the mission objectives, the level 0 requirements were completed. Now the level 1 requirements are almost completed. And we are already working on the level 2, level 3, which are under major development. So you can see the amount of information that's been discussed and decisions have been taken on. So this is, I would say, very good progress in just a little bit more than 6 months. So this just to give you a brief overview on the technology. So on the left, the small diagram is the whole Aerus. So you can see the ground segment, so I can basically see it, the space segment, and then the different, and launch segment, sorry, you can see different modules, so the spacecraft itself, the payloads, and the large diagram is just the spacecraft itself. So you can see the amount of systems that have been designed, developed, and all this must be fit together so that the satellite can fit into a very small half milk carton size satellite, and that the mission is complied with. So this is the work that we've been doing. And now, so I would pass the word to Saya and André. So please move.
Yeah. It's good? Okay. So Saya is here participating in the project in two main activities. First, we are working with the rest of the departments to develop the spacecraft itself, the platform. So we are designing both the structures and selecting the systems that are going to be flown inside the spacecraft. This will be a 3U satellite, so as José said, not more than a milk carton. So 30 centimeters by 10 by 10, and it should weigh less than 5 kilos. So it's a quite small spacecraft, packing a lot of systems, and you can see there on the right the systems that we are planning to carry. This is all being rearranged, I'll say, almost every week, so we can make sure that we carry enough systems and the systems that we need to perform the operations that we want to achieve. Yeah. And we are also, that's the other activity that SEI is now working, is the Data Analysis Center that will collect data from the different sources, be it from the Aero satellite or other open available sources. It will integrate that data, label it, and store it so users can access the data hub later on and have access to data that is both raw, in a raw state directly from the satellite, or that has been integrated and processed to level 1, level 2, and we are even discussing if level 3 data should be or not available at this point. This is a huge endeavor that we have, and currently we are testing the system with data from Copernicus and other available open source data, so we can test the system before the satellite is launched.
Tiago?
Okay. I was doubting that the sound was on. So in our case, we'll be providing the camera. If you go, I think 2 slides back, you can see where the camera is within the nano satellite. Yeah, so it's at the top over there. It looks like a compact camera. So at the top on the right there.
No. Lower?
Yeah.
That's the camera.
That's the camera. So it takes up less than 1 unit of the 3 units of the nano satellite. In principle, there should be room for even a couple of things over there. The camera is characterized by having basically two boards. One is the sensor board that you cannot see here because it's really along the optical path, and the other one is the processing board, which basically takes all the image and processes it in order to provide something that's closer to a cube. The reason why we call it the cube is that it has 150 bands. They should cover between 400 and 900 nanometers. Each one is about 15 nanometers wide. So there are a lot of them, and they serve to basically we can take information on things like large-scale algae blooms and large plastic concentrations in the open ocean. The camera is relatively small. We're still studying exactly what the field of view is going to be like. That's why I've added there TBC, because it's constantly being updated as we know more about what the conditions will be in practice. It's a relatively light camera. It won't add too much to the weight. When you want to go to 5 kilos, that's what you want to do. And the ground resolution will probably be a little bit worse than what we have there. So on the right, you can see what the technology is like.
Let me just ask you to approach a little bit the microphone.
Oh, okay. So on the upper right, you can see examples of what we have already done. So in much of this technology is coming from a previous exercise in the scope of the infant nanosatellite. So it's basically the same technology, the same type of sensors, and we're applying it to a slightly different mission so as to qualify us to get into the Atlantic constellation. So that's basically it.
Thank you. We're now going to hear Carrie, I hope. Carrie, welcome.
So much for inviting me. It has been our joy to participate with the Portugal team. We have a lot of very fun technical discussions. So MIT's role here is to support with analyses and hardware decisions in putting the satellite together, deciding what to bring together and how to put it together and what things to do. So we have a great graduate student team who are probably watching from MIT, who have very much enjoyed working with the Portugal companies and teams. We had students on this slide, for example, help put together predictions of orbital power. So we use analyses to tell how much sunlight will fall on the solar panels depending on where the satellite is in the orbit. And then we look at different orbits to help the team choose what the best orbit will be for their satellite to look at their target region. So on this plot, you can see the lines. The line plot is from a graduate student named Miles and Peng and postdoc David, who did an orbital power analysis for the satellite. And then they also optimized and to help the team decide which orbit, which rocket to go on, to look at the target region over the ocean, which is shown in the top right of the slide. We've also had students look at the link budget, so starting to look at the different types of radios and what transmit power and what antennas and how many of them to have to both talk to the satellite and get the images down. Our team's also been working with the imager team to figure out, okay, you have light coming in from the sun, bouncing off of the earth, coming up to the camera. How big of a field of view, how many photons do you have to get in, and how many colors can you see, and how well can you see them? Some of the other work that's on this current slide that the students have been helping with is once you take images over the target region, around the oceans, around Portugal and the coastlines, what kind of software, what kind of algorithms, code can you write to help look at those images and automatically determine what is coastline and what is ocean, so what's land and ocean. So you can decide what regions to use for different types of analyses. There's also the problem of clouds. You always want your images to be clear, and so there are algorithms that we're helping implement that will help automatically determine whether there are clouds or no clouds in the image. So maybe we can do a better job of deciding which ones to keep and send down or which ones to retake the picture of. So there's been wonderful work done by our graduate students. I should name them all, but they're all on the slide, so please get a copy and you'll see their names credited to the work that they've done on some of this project. So we're really looking forward to getting the hardware ordered and built and watching everything come together and then being there to cheer on the launch and see the data come down. So the team's doing a great job. Thank you.
So I'd like to thank my colleagues and make a reference to Elder Silva, who was supposed to be presenting the project. Unfortunately, due to family events, he could not come here. So on behalf of him, I'd like to thank you for your audience and help presenting the project.
Thank you all. I have now a few questions. So feel free, the four of you, to jump in and answer the question. So one of the questions is, will Aeros nanosatellite be focused on a specific geographic area?
Well, we want to have it deployed from the International Space Station. There are still choices that we can make. I would say for the time being that the concentration or the focus would be the North Atlantic, but other areas, as it's the LEO satellite, will also be covered. So.
Good.
Maybe I can add that the project from the beginning was focused on the extended Portuguese continental shelf. Of course, this is a large area that we need to monitor as a country, and we need to take care of our continental shelf, because then we have a bunch of resources there that need to be monitored and then can be explored. But of course, during its lifetime, the Aeros satellite will be flying all over the world, and we'll take every opportunity to monitor other areas and collaborate with other research institutions, so we can then have a product that works for us, but also for the rest of the world.
Okay, good. I have more questions. So how does a nanosatellite manage to collect data from the oceans, and what kind of data is it collecting? So we have different people, not just people from space watching us, so this is why I'm asking this sort of question. And to complement this, is it just surface data, or can you get information about the ocean floor as well?
So I will start.
Lots of questions, so feel free to answer.
I will start, but this, I think Tiago can speak a bit more about the sensor. But bottom line, so yes, it will be mostly surface. The reason being because the light coming from the bottom or any surface below the sea level surface, the light will obviously be absorbed or transformed, let's say, as much as goes through water. So the satellite will be mostly tasked to provide information about the sea level. We can obviously combine this with other information. As said, we will have a data center, and this data center will be able to combine data that comes from from underneath the surface, also from other models and any type of information. We also will have a radio that will be able to collect information that's sourced from, for instance, animals with tags. So there are different ways to see. And maybe, Tiago, you can add a bit more on the sensor capabilities and what can be extracted from the hyperspectral camera.
Yeah, well, so the camera obviously can collect only data from the very surface of the ocean. However, it can also collect some data from the surface of land. So from the ocean, or at least in the ocean, we can expect to detect some things like algae blooms, as I mentioned, and also plastic concentrations if they're large enough, because we don't have a very high resolution in this imager. The reasoning is that we have very narrow bands and we need to collect light from them. This is one of the issues that we have to fine-tune with both the people from Edisoft managing the project, as well as from MIT, who are giving quite a bit of input in this. So we need to know exactly what to go for in terms of resolution, so that we can collect enough data to do this kind of detection. But basically the camera is quite suited to observe the ocean in this respect, but also to observe land, and in that way to detect things like chlorophyll is one of the things that can be really detected within the visible field, the visible spectrum, because we are covering basically the entire visible spectrum and a little bit of the lower end of the near infrared. So this is essentially what we can expect to detect: chlorophyll, algae blooms in the ocean, plastic. This is an open field of research in terms of detection of plastic, so it's not entirely clear yet that just using the visible part of the spectrum, this is feasible, we might need to use later on cameras that are sensitive to things like the shortwave infrared and such. At this point, however, because we are limited to a 3U satellite, we are using a camera that's using basically a COTS sensor. This is the reason why we are dealing with just this band, and we have the limitations that we have.
Good. Following on that, I don't know if you want to say, feel free to say more things. Otherwise, I think it follows really well, because the thing I would like to ask you is this technology complementing underwater expeditions that take place in the deep sea? You were mentioning chlorophyll and other things. So in my mind, it does, but I would like to hear from you specifically how it does.
Yeah, so as José Freitas also mentioned in the very beginning, we are only able to collect data from the very surface of the ocean. The idea is that we can combine that with other data taken in situ, either from automated vehicles on the surface or submarines and that kind of thing. There's, as far as I know, there's plenty of research being done in Portugal, and even through these programs such as MIT Portugal, that's dedicated to this. And so I believe that we'll be able to cover a lot of that with the help of the satellite, but not just this project in particular.
In fact, the mission that we are planning, there are, I would say, 3 main objectives: the hyperspectral camera that will take pictures from the surface, and we are also getting to work with animal tags that are being developed at SEI and in collaboration with the University of Azores. So we are gathering the data from those tags and adding that to the data hub that we are developing in this project. And again, we also have autonomous vehicles that SEI is working in, both surface vehicles and underwater vehicles. So we can all gather that data in the data hub and then give the users an holistic view of a water column that is much important for different applications. And we want to have that general overview of the systems, and not only have a satellite flying and taking nice pictures of the ground or of the ocean, but also adding information to that, and adding information to conventional missions. That's the main goal of a nanosatellite mission, is to complement what we have at this point, and from that take added value information.
So if I can just add something, to give you an example, with the satellite we can cover things that are several tens of kilometers wide. We have in other projects capabilities such as cameras that can be on board drones that collect data that is much higher resolution in nature, but then just covers very narrow areas. And this is the case in one such project where we're collaborating with SEI, where we have a hyperspectral camera again and a thermal camera. So this is not just happening in an isolated way. We are trying to cover as many different aspects of it and from as many different places as we need.
Following on that, and as you know, the MIT Portugal program is all about collaborations that already are in place, but also others. So is there any mechanism in place already in your team to integrate information from other research groups working on oceans, both in Portugal and in the US, of course?
Well, there's the data center, but Carrie, I think you were about to, I think Carrie, you're trying to say something? Carrie?
Yeah, sorry, I know the delay is significant.
Yeah, you were saying something, right?
Yeah, the MIT team has a collaboration with a Woods Hole Oceanographic Institute, and there are some researchers there that we are working with, in addition to the MIT team and not only the engineering department, but the Earth, Atmospheric, and Planetary Sciences department, as well as Woods Hole Institute. So That's all I wanted to say.
This is exactly what we want to hear. It's collaboration, so I'm always very happy to hear that. So, simple question, but again, as I told you, there's lots of people watching us on YouTube that are not from our research area. So, in terms of your nanosatellites, try to explain that to somebody that is not from the field. How is it in terms of size, and how does it compare to a normal size satellite in terms of functionality?
That's a really good question. I wish that we'd have one here, because it's really very small. It's, again, 5 kilo, 30 centimeters by 10. So but by no means it can be considered as low performant or lack of ambition. So it's not only a question of cost. So this satellite was calculated, and I mentioned to have the 3 payloads. So 3 payloads is actually quite ambitious. So we have the hyperspectral camera, the GNSSR, and also the radio UHF, VHF that can collect the data from the tags, etc. So what is the difference? So first of all, the satellite will be on a low Earth orbit. This means that the satellite is prone to have the influence of gravity and also friction with the even thin but atmosphere. As the satellite is small, it doesn't have say easy mechanism to correct trajectories and run away from Earth. So this translates into a lower lifetime. So a satellite like this should have a lifetime around 6 months, 1 year. So, but then again, this is not negative, because the trade-off is, instead of having expensive satellites but that become obsolete within years, you can have smaller satellites which also cost less to launch, which is important. And also you can just replace it with newer satellites, or even better, you can just complement it with a wider constellation. We have 2 for the price of 1. The other limitation, but then again, our mission, the requirements will be met with these requirements, is that you don't have, it's more complicated to have active sensors. So active sensors would be like a synthetic aperture radar, which is excellent for maritime surveillance, but then it needs more power since you have to transmit. And obviously, power is a limitation, because it means obviously batteries and solar panels, and the equation doesn't go that way. So this meets our requirements. So there are many CubeSats which are becoming not only a research topic, but also entering a commercial business. What is the challenge for us? Well, the challenge for us is to manage the budget, so link, weight, power, etc., very tightly, so that with the platform we can have the right conditions for everything to operate, and also work, and this is very important, on miniaturization, so onboard avionics, and this is what, as much we gain a little bit of efficiency of everything, we have about the comparison. Well, yes, so comparison is good. For instance, the Sentinel-2 satellite Earth observation is 1 ton. Okay. So you can see it's 200 times.
It's a car. It's basically a car.
And I don't think it does 200 things more than well, does things better, of course. A satellite to have a SAR radar is in the vicinity of that. For instance, the PASS satellite built by Airbus has a SAR radar, and it's, again, 1 ton big, and 1 ton costs a lot to launch. And for a very high resolution optic, I would say a satellite, for instance, the GeoSat 2 is about 300 kilos or so. So we can do a lot with our 5 kilos. So anyone would like to add anything?
Yeah, maybe I can add something, which is basically, if you look at the bottle over there that we have on the table, the nanosatellite is just a little bit longer than that, and just a little bit wider. Yeah. So it's on that order of magnitude. It's a really small thing.
Yeah, it gave us a good idea of the size and everything, so thank you for that. So I have another question. So Aeros is a good example of a project that brings together partners from industry, and you're our example of that, research centers and universities, both in Portugal and at MIT. What are the benefits that each stakeholder has in participating in a consortium like that? And do you think you could achieve the objectives of this project without having a partner in industry or in a research center?
Well, I think each partner can shed some light into their say personal or corporate process. In the case of Aresoft, we can say that as we accepted to lead this project, we think this consortium has all and the exact number of pieces that we need to put this together. So we have complementary skills. There are partners with payloads, some other have models, some have experience in assembly, developing data centers. Aresoft is expert in avionics, mission houses, also ground systems. So I would have to present a table with each of them. So, well, the point is that all this is important. I think a good result is that we managed to create a project that's inclusive. So there are no partners which don't have, a very specific skill, which is added value. And also the cross-Atlantic perspective is really good. So MIT has been also very enthusiastic, have far more rich experience in this kind of platforms. And also the vision from the other side of the Atlantic enables us to have a full Atlantic perspective. I think this is very important to understand how such a system can be valued or bring added value to the both sides, and also to foster the scientific relationships, which I'd say is a long-term benefit, as well as the cooperation between industries. So this is Aresoft's view. So I mean, would like to hear also opinions from other partners.
Well, I should say that we, as an institution, CEIA, we cannot exist in isolation, basically. So we need other partners to do other aspects of the work, and only by working together we can achieve goals like the Eros constellation. I should say, in my personal perspective, that I've been working in CEIA for a few years now, and did a PhD on the Faculty of Sciences. So doing this bridge between the university and going a bit more closer to the industry, although CEIA is not a company, we see a lot of projects that only work between having collaborations between entities. So only through hard work and institutions like Aresoft, Spinworks, MIT, bringing together their knowledge so we can achieve a specific goal. Without it, we are only working in hypothetical terms, or we're just doing our small system that does not have an use in this world, because we need to work with others to have that.
So in our case, the way we see it is Portugal is still not entirely geared towards having a satellite on it done by a single company or entity. Most of the participations that we have had before in space were things that were really isolated in nature. So it was a specific entity that was doing research in a specific field or producing a specific part. And the way we see it in Eros is that we have just the right amount of entities in order to be able to produce something from end to end rather quickly. So it doesn't mean that it will always be like this. It doesn't mean that it's not. But for this particular project, what I think makes it feasible within the time frame that is for a project like this is that most of the people involved were already good enough to participate in this and make it happen quickly and with a high degree of certainty. So that's what I think is the key aspect.
Carrie.
Yeah, I would agree that everybody has a very high level of technical expertise. Everybody's very enthusiastic and high energy. And I think bringing all of the different skill sets together to build a satellite takes everyone. It takes electrical people, software people, mechanical people, thermal people, data analysts, a lot of software. And I think a lot of great managers and a lot of good resource management. And so having a team that contributes all together at that level is really what makes a good space mission project happen. And having the input of the scientists to drive the instrument development is also part of it. And I think realizing that it takes steps, that this first satellite will be just a first demonstration of the basic functions, and then we can go on to grow and expand from there and continue to work together. So lots of opportunity going forward.
Carrie, one more question for you. What do you think are the advantages of collaborating with Portuguese colleagues from industry and also universities?
We get amazing students and talent from all over the world, and I think there are a lot of truly excellent, innovative, creative, and hardworking researchers and students in Portugal that I don't know yet. And some of them I do know and I have been very impressed with. So for me, it is exciting to find and to collaborate with and see things come together with a very talented team. I think the expertise that they have in understanding ocean systems and the importance of marine systems on the culture, on commerce, on the climate and the world is critical, and it's important to get for us to grow by learning and sharing. And I think understanding each other and working together is one of the most important parts to me.
Thank you. You mentioned their students. So we have here two of our MIT Portugal students, and as you all know, students are a crucial part of the MIT Portugal program. So I would like to welcome again Rita Dantas and Rita Pombo. They are starting their PhDs, as I said, with the MIT Portugal FCT scholarships in the scientific area of Earth systems, oceans to near space. So I would like to ask first Rita Pombo to give your slide, please.
Can you hear me?
I think you need the pointer. No, I think, yeah.
No, it's okay.
Yeah, okay? Okay. Let me just wait, and that will place your presentation.
Good afternoon,
yeah,
first of all. I would like to thank the invitation for this remarkable meeting. There was already a broad debate on the main challenges and opportunities for research and for innovation as well. My name is Rita Pombo, and this year I was granted a PhD scholarship within the MIT Portugal partnership. The PhD proposal lies within the MPP strategic area of oceans to near space. The title is Feasibility Study for the Deepwater Development of the Port of Leixões, and the host institution will be the University of Aveiro in collaboration with the Port Authority. So, why this title? As we all may have noticed, the continuous growth of the global trade is driving the shipping industry to readjust and adopt more efficient and cost-saving measures, which means the use of bigger ships to transport more cargo. However, it's important to emphasize that not all port infrastructures, in fact, the majority, is not yet prepared to receive those vessels and lack of adequate equipment. So, we are talking about a very important issue that directly affects citizens and the societies that are obviously dependent on. And this leads to the second point. How should ports react? The solution is maybe not to be left behind and try to fit and find adaptation strategies to stay competitive in the logistic and supply chain. In this case, Portugal has a natural competitive advantage due to its location in the Atlantic coast, but so far only seen as deep water infrastructure, and this could be optimized if Leixões could also expand into a deep water solution, since it's the second largest national port and benefits a high density industrial hinterland. Therefore, and to jump to the last point, the goal is to say in the end of the PhD if it is feasible or not to go for an engineering solution like this, to accommodate a higher percentage of the world current fleet of trading ships in Leixões. And so to conclude, this PhD lies within the MPP commitment to strengthening the national competitiveness, in this case, through the national port system.
Thank you. So you propose to assess the feasibility of a deepwater expansion solution at Porto of Leixões, resulting in the first deepwater port terminal on the Portuguese northern coast. What are the challenges that you are anticipating?
No one can anticipate how bigger the next ship will be. Every few months, a new record of biggest ship arises. So they are already longer than the Eiffel Tower, so no one knows. Luckily, it's already proven that there is a limit above which it is not worth to grow. But what I meant is there is no one-size-fits-all solution. It's difficult to stay always in the forefront of this business, and we will always have to deal with the unpredictability factor. For example, what happened in Suez Canal had huge repercussions at the global scale. Also, disruption events like the COVID-19 pandemic may also change the course of things. So it is intended to assess the vulnerability of the port infrastructures to respond to these external threats and its capability to respond to this crisis.
Okay, good. So if you are successful, and we are all cheering for you, so very hopeful, your research project will allow an increase in the maritime trade to the Northern Europe. How do you think we may contribute to an increase in maritime trade with minimal impact on the ocean's quality and life?
The marine industry has numerous impacts in the marine life. For example, sound pollution may affect the marine animals. For example, the animals could rely on sound to communicate, to feed, for orientation, and that's one problem. The other thing is, for example, the ballast water. This happens when a ship arises to a port and unloads cargo. In this case, it needs to uptake coastal waters to balance. And then, for example, in the next port, it will discharge the same water. And this is undesirable because this water could contain bacteria, virus, and plants that are not native and could endanger the second ecosystem. There are already other impacts, for example, atmospheric pollution, but in this project we are promoting the use of bigger ships, which means that the same cargo will be transported in one ship. So in the end, we hope that the number of the total active ships will be lower. So the environmental impact per cargo unit, per unit of transported cargo, will be less. And so far, for a given distance and for a given cargo, the ships are the mean of transport with the lower footprint.
Thank you. So Rita Dantas now. Would you like to tell us a little bit about your project? We'll show a slide now. Just give us a minute.
Okay. Good evening, everyone. My name is Rita Dantas, and I'm from University of Porto. I was granted with a PhD scholarship from MIT Portugal and FCT. My project is entitled An Integrated Multiscale Fatigue Methodology Applied to Ocean Structural Systems. It's a very long title. I'm going to try to explain you in a more simple way what are the main goals of my work. So with my project, I intend to give new and some contributions for the development of wind energy production. There you can see a picture of a very interesting project. It's a wind turbine. In fact, it's a floating platform that was installed in the north of our country some months ago. It represents a really important milestone because it's probably one of the major floating platforms that's ever been installed. And when we look to these kind of structures, we usually think how much energy can we produce. However, it's also important to think how long these structures will last, how we can extend their lives, because when we have some product like this, it's also important to see the impact in terms of their life cycle. So in order to do that, I proposed a methodology based on fatigue. In a more simple way, I can summarize fatigue as a way to establish a comparison between the loads that are present in these kind of structures and their lifetime. So in order to do that, I will analyze some critical details. There you can see a very usual detail that are present in offshore structures. And my idea is to conduct some numerical studies, taking into account the loads that are present on these structures. And besides that, I also intend to analyze not only the structure, but also the material, the main material characteristics, mainly in terms of fatigue. So I will study the initiation of the damage, but also how the material can deal with damage. And then, to conclude, usually in this kind of analysis, we need to deal with some uncertainties, so I'm thinking also to conduct some probabilistic analysis.
Good, thank you. So how do you think your project may contribute to a better use of renewable energies?
So I was saying, usually when we have these kind of structures, we analyze the energy that they can produce, and I think with my PhD plan, I intend to analyze the structure, evaluate the damage that is present, and extend the lives of these structures, because I think it's also very important to ensure that these structures will be ecological, not only in terms of energy production, but also about the structure.
Okay, so now I'm going to quote some phrase that you wrote on your PhD proposal. In Portugal, the production of marine renewable wind energy started in 2011 with the installation of a 2 megawatts floating wind turbine platform. Recently, in 2020, the first offshore renewable wind farm, Windfloat Atlantic, with a capacity of 25 megawatts, was inaugurated. How do you think Portugal will be in 10 years' time regarding marine renewable wind energy?
So the Windfloat that I mentioned there is the project that I showed the picture in my slide, is a very important milestone in our production of energy, because that kind of structures allow us to install our turbines in some regions of deeper water, and our coast has more region with deeper water than the kind of regions of coast where we can install some fixed structures. So with that, I think that at this moment in the probably in the next 10 years we will see a tendency of growing of the energy production, because we were being able to not only install more structures but also install bigger ones with capacity to produce more energy.
So I have two more questions for the two of you, both Rita Dantas and Rita Pombo. How do you think the MIT Portugal will be crucial in your project? Do you think it would have been different if you had another scholarship or not? What are your opinions on this? Or tell me your experience of why did you apply specifically for this scholarship? The two of you.
Okay, can I start? Yeah. Well, I saw the main topics and the main research fields of MIT, and the fields for me are probably the most interesting ones at this moment because of the climate changes, and also were the main topics that I wanted to study and to conduct my scientific work. So it was one of the main reasons that I applied to that scholarship.
Within this partnership, we can participate in meetings like this. We can change ideas. We can debate, and also I always liked to continue to work within oceans-related topics that are my field of expertise within the civil engineering. So this is promoted within this program.
That was actually my following question, is how do you think, or what are your ambitions after your PhD project? I know we are in a COVID era, so things change, but what are your ambitions for after? And many things may change, but what are your ambitions? Tell me a little bit about that. Both of you, obviously.
It's a bit difficult to answer to that, but for sure, I desire to continue to work in the research field. I would like probably to cooperate more with the companies, because I think it's also important, not only, as someone was saying, it's very important to cooperate and comprehend how the world works and what are the needs of the companies and the industry. So I think in the future, I would like to continue to work on research and probably in this field, but more in cooperation with companies and something like that, I think.
As my colleague says, I would also like to be involved in industrial environmental and bring the knowledge acquired into the real life. So to contribute to the Portuguese economy and research with the PhD work.
Okay, thank you. I'd like now to come back to José, André, Tiago, and Carrie to wrap up. What do you think are the next steps? I know you're doing lots of work, as you showed on that table, that we couldn't read anything, so it is a good sign in this case. But what do you think will be the next steps after this project is done, is wrapped up, and you executed all the money, and you're very happy, you're going to be very successful? What do you think are going to be the next steps for the four of you? Different views, what do you think?
Well, first I would like, so we're not in this for the money, so like you state, this is co-financed, so at Edisoft, we have to present a clear business plan to be allowed to spend 1 cent in. So we're not this for the money. This is project. Self-standing would be financially negative. Of course, there are many intangibles or even tangibles. So first of all is that we are working on a mission that will be launched. So this is, I would say, the difference between being on a football, soccer in the other side of the Atlantic. Training versus a actual match. So there's a delta, and it's important again, Edisoft will not be able to do this on ourselves, nor do we want to. So for this to become something as in the shape of a constellation, not just one satellite, having partners on board, present or not present, is important. So we want to keep this team rolling. Obviously there are internal benefits. So we are at Edisoft, we keep developing a line of work that we have been done previously. So build on competence and expand. We don't think the project will end after the 31 months period finalizes. So there are many options. There are new programs being talked about, recovery plan. So there are options, and we have opportunity to, after we try this, it will be hopefully financially sustainable. Then we could expand the constellation, and maybe I didn't mention before, we can scale up the platform. So the Aeros second generation doesn't have to be 3U. It can be 4, 5, 6, 7. You can think of this as a computer rack where you can just stack servers and switches, and you can use racks this size, so it's up to you. Then you have to cater for power consumption, so you can see the logic, but there's space to progress, add new payloads. I mean, I'll say there's a lot of opportunities that I think we only see the tip of the iceberg, and the iceberg being a positive way this time. So this is our perspective.
So yeah, the constellation is the obvious answer here. So building a constellation and then starting acquiring data. But for us, the constellation, be it Aeros or any other in situ asset, they are only platforms for acquiring data. For us, what comes next is processing that data and adding value to it so we can supply information that is needed to either universities or paying customers that need specific data, both from the ocean and land. So we are looking at how we can then help those customers and help those institutions to get the data that they now know that they need, and actually the data that they foreseen that they will need in the future. That's our goal. Building a satellite is just building a platform for acquiring data for us.
Well, in our case, we've been trying to build these cameras to work in space for quite a bit. We started out with 4 years ago, for something years ago, with this, with the infant camera, and we're looking forward to go on with this. We have other projects, including in the scope of international partnerships, where we're actually building an entire platform and in collaboration with other entities here in Portugal. So that's another thing that's interesting for us. Then, as you know, Zita, our whole history as a company has been towards planetary exploration projects, and this is one thing that we'd like to work on, using the same approach that we see here for the nanosatellites that we're building. And finally, one thing that I think is really, really valuable for us at the company, and I believe for everyone involved, is to establish a cooperation that is steady between everyone involved, including with MIT, of course, where we can just take this as a point of departure and see where it goes from there.
Carrie.
Yeah, I think there's a lot of opportunity in the process. There are technical skills developed. The instruments on the spacecraft that are being developed. I think everyone will get great value from the data products, from the images, from what the radios are able to pick up from data, from the GNSS reflectometry, looking at the surface roughness and winds, ocean color, probably how salty the ocean is, the temperature of the ocean, the coastal regions, seeing ships move, being able to track them, being able to better predict conditions for them, better figuring out transport and logistics, reducing pollution. I think this will grow. I think it will be able to build on the skills and the initial first steps to having a many spacecraft constellation that is operational. So maybe the next constellation will be 6 satellites that are slightly bigger. And then the one after that might be 10 or 20. You'll have ground stations, you'll have people who are taking the data and getting it to the people who need it, communications, commerce, scientists, you know, commercialization managers, agriculture managers. I think this will grow, and having this capability and establishing that this kind of thing is something that is valuable, and that there is a team with skill and vision to move forward will take us to the next level and improve both the environment and commerce and communication all together. So I think that's the real opportunity. And I do like the mention of the planetary exploration as well. There's no reason to stop at Earth, right? You could take some of these same instruments and use them for later exploration of other worlds as well in the solar system. So, so I think having the experience and expertise in building these instruments really does bring opportunities not only for now, but also in the future.
Thank you. I think the future and our ambitions, your ambitions are all very good. I think the future is bright, both in this project, but all the funded projects from MIT Portugal, also our students, they're doing a brilliant job. So before I close the session, and Pedro Arezes is coming back to the stage again, but I'd like to thank again all our speakers, both here online. Carrie, thank you so much. Also like to thank people watching here and watching us through YouTube. And I would like to welcome back again to the stage our National Director of the MIT Portugal Program, Pedro Arezes. And let me just say this and thank again André Breda that opened our session, the student that opened our session. So thank you very much.
So thank you, Zita, and thank you for this perfect time management of the session. It was really sharp on the planned time of ending this session. And so I'll start to thanking to our last speakers, Rita and Rita, and I can assure you that Rita was not a criterion for the selection of our PhD students, but your presentations and basically your PhD plans are really, really ambitious, and we hope and we look forward to have more news about your work. Thank you very much. And for the Aeros project, thank you very much for sharing with us your amazing contribution here, which is basically space-related technology and science. And I think it's really important for us to have this input from your project. And basically, apart from that, it's clear for us that this is a clear, strong and international partnership and collaboration, which is the main core of this MIT Portugal program. We want to have international partnerships to foster Portuguese science, but obviously framed in this context and with this link with MIT. And as I see it, basically, the mission of MIT Portugal program goes beyond bridging both sides of the Atlantic. It's not only link Portugal and MIT, but of course, we want to be an active contributor to place Portugal in a leading position in the space field. And we have a lot of contributions during Ciência about space, and we also have the representatives, and I think I saw Ricardo, our PT Space director. Yeah, Ricardo is still with us in the room. And I think this is part of this broad strategy about fostering the space-related research in Portugal. So before finishing, let me just take this opportunity to share with you, basically to do some marketing about our activities. And so I'll just synthesize some of our initiatives that we have planned for this year. So we have now 40 PhD students like Rita's, supported by FCT grants, which will start their doctoral studies soon. Some of them have already started. And we have already launched a new PhD grant
call that closes next Friday. So if you have someone interested in these PhD calls, they should be quick because the call will finish next Friday. But we are also opening a new call for exploratory projects to spearhead Portugal's innovative capacity in science and technology. And we meet regularly with our flagship projects to share the latest progress on the ongoing projects, like we did basically this afternoon. And these projects are of high relevance for Portugal's development in the MIT Portugal research domains, and we want to ensure that they are successful. And we are doing a meeting soon, which will be, at least it is planned for Lisbon, in next month, but of course we need to see more about this pandemic situation and see if we have to move to an online format. But this year, and for the first time, we will hold also a marine robotics summer school starting next July 19th, where students will work on assembling an underwater glider, which is a funny thing. I think I won't say anything more about the glider, but you need to check probably through our website, in which probably we will have or put there some more detail about this summer school. And last but not the least, of course, we want to invite you to join us at our MIT Portugal annual conference, which will be in September the 20th, at the Porto Cruise Terminal, which is a nice building that Rita had in one of those pictures in a small scale, but it's a very nice place. So actually it's not Porto, it's Matosinhos, which is a city very close to Porto and very, very close to Sé as well. So hopefully we can have you there. This year's conference title is Science and Technology as the Catalyst for Tomorrow Living Spaces, and we will have an interesting session regarding, for instance, technological free zones that will help enable the testing of tech-led products and services and create an appropriate environment for innovation. So this year is also the year we mark the beginning of the 15th anniversary of the MIT Portugal program, and we plan several moments to celebrate this date. So we hope you can join us. It will be a great honor to celebrate this legacy with you. Thank you very much, and thank you.